This is Group 336's Robot Project Assignment 2. So for part 1, our optimized parameters are as follows. For open loop control, we increased our ticks before turn to 37, decreased turn time to 0.45 seconds. For our hybrid control, we increased ticks before turn to 27, but also adjusted piston on-off time to 0.4 seconds respectively. For closed loop control, we decreased KP to 0.2, but added more checkpoints on the desired position list. This creates better pathing for our robot. We finally adjusted piston on-off time as well to 0.4 and 0.8 seconds. The average scores and standard deviations of these three methods can be seen below. As for the t-tests, it suggests that the open loop control is vastly different from and inferior to both hybrid and closed loop, with a p-value significantly less than 0.05. However, between closed and hybrid, the p-value was 0.1198, which suggests that there is not a significant difference between the two methods.
For the pseudocode, initially in our setup, how we're going to set it up is initializing all our variables, such as time, position, where the checkpoints are, initial turning angles, and everything like that. And then if we go on to the next slide, our loop setup, or void loop, kind of one thing we have to worry about is firing the piston. And that one, we compare the last time the piston was fired with an if statement. We also have to calculate the current position of the robot, which is, calculate the distance traveled from the reed switch. You also calculate the angle using the compass reading to get a new position. And then for course corrections, what we do is we have to compare the current position to the checkpoint position and keep on updating that. So you compare them. And if the robot angle is not equal to the relative angle comparatively to the checkpoint, you move the servo motor to correct for that. And then the last thing is changing checkpoints is if you get within a certain distance of a checkpoint, you have to then move on to the next checkpoint.
Alright, so hi guys, my name is Luis, and I'll be guiding you through the experiment portion of our project. So, using the hybrid control simulation, I decided to test average score versus increasing KP. So, each of these graphs shows the robot, and with increasing KP values, you can see that after it crosses the trench wall, the robot gets increasingly more straight with the higher KP. As you can see here, this is really, really straight. So, I decided to record the score, the average score after 10 runs with each KP value, and I found out that in order for the robot to consistently get to the end and get full points, you need to have at least a KP of 0.5. So all the results are in this graph or in this table, and I put all the results of the table in this graph right here. So yeah, thank you.